Thank you very much for joining me here. Glad to be here at Berlin Buzzwords, and guten Tag, everyone. And today I'm here to talk to you about the OpenSearch project. But just to get to know the audience here with a show of hands, who is familiar with the OpenSearch project? Okay, we have some that are new to the project. And from those who raise their hands, who uses that today in one way or the other? Okay, we have some users. First of all, the users, please approach me. Some of you already talked to. Happy to learn how you use it and get your feedback on that. But sounds good. My name is Dotan Horovits. This tweet that you can see here is actually from Berlin last year. That's where we held the OpenSearchCon Europe, the first Europe edition of our regional events. Was very excited to be a speaker there. And this year we held it just 2 months ago in April in Amsterdam. So keep your eyes out for the OpenSearchCon Europe for next year. I'm an evangelist for the OpenSearch project. I work for AWS open source, global open source team, where my focus is primarily on OpenSearch. I also do other things related to open source observability. So if anyone's interested in this domain, happy to talk about chat after the talk. Besides AWS, I'm also a CNCF ambassador. CNCF is in the Cloud Native Computing Foundation, the open source foundation where you'd find Kubernetes, Prometheus, OpenTelemetry, Argo, and many other projects that you probably use. So if you have any questions about Cloud Native Stack, also happy to talk about the chat. That's not that topic. And also I run a podcast in English called Open Observability Talks. Already a 6th year in a row. So if you're interested in these topics, do check it out on your favorite podcast app. And let's talk about OpenSearch. I see that some are not familiar, so I'll do that just briefly. OpenSearch origins in a nutshell. It started as a fork of Elasticsearch back in early 2021 after Elasticsearch and some other components of the Elk stack have been relicensed away from open source and into non-open source license SSPL. And obviously, users still wanted the open source alternative for search, for analytics, for observability. And AWS stepped up and forked the project. That was the origin 4 years ago, based on the last Apache 2.0 licensed version of OpenSearch, of Elasticsearch. And I'm glad to say that the project has moved on and progressed a lot in these 4 years. You can see some of these stats here. We've already surpassed 1 billion downloads of the project, which is pretty cool. We've released 25, actually more than 25, I need to update the slide, releases, 130-something GitHub repos. It's a massive project. It's all thanks to the community, which powers OpenSearch. You can see some of the stats here, 3,600 members in our very active public Slack. We have forums, 6,800, if I'm not mistaken, at opensearch.org forums. And most importantly, over 1,000 contributors from more than 30 different organizations. And the results speak for themselves. If you go to DB Engines today, you'll see that it's the top fourth search engine, multimodal engine ranked in DB Engines, and it's been consistently so for quite some time, so pretty cool to see that. On the community side, the biggest news that came just in September from Vienna, from Open Source Summit, is that OpenSearch has become part of the Linux Foundation. So today it's a foundation-led open source, a neutral project, not led by any or controlled by any specific vendor, a neutral playground for collaboration. We have a governing board in place. We have a technical steering committee. All of them are there. We have, as you can see, organizations such as Uber, which we have also fellows here on the audience, SAP, NetApp, and more that have already joined and are now helping to steward the future of the project. So really exciting to see the community build up around that, now foundation-led. That was a bit about the history, and now let's talk about what the OpenSearch stack is about. So clearly, first and foremost, there's the OpenSearch core. That's a distributed search engine built on Apache Lucene. We have many Lucene folks here, so no need to explain there. Storing documents, and in addition, very importantly, it can also it also has the vector database capabilities beyond the lexical search that you know from the basic Lucene functionalities. That's the core. I'll talk more about the core. Don't worry about that. Then we have the OpenSearch dashboards. That's an open source data visualization user interface, essentially, where you can run your queries visually on the data, create dashboards, define alerts, and all the things that you'd expect. Also, team collaboration, reporting, data management, and so on. And the last important piece in here is Data Prepper. That's a lightweight data collector for enriching, transforming, and aggregating your data. These are the main components. There are obviously also client libraries and integration with a broad range of third-party tools. I'll talk a bit about that, but these are the main components. Now, let's talk about how people use OpenSearch. And, you know, like any database and search engine, it can be used for many different use cases, but broadly speaking, it falls into these 4 buckets, 4 categories. First and foremost, obviously, search, like the screenshot, like things that you'd see, enterprise search, catalogs, e-commerce, and so on. It's also widely used for log analytics and observability use cases. And we also see growing use of that, of OpenSearch project for AI, ML, backed applications powered by the vector database that I mentioned, and lots of integrations with AI frameworks that I'll show soon, like LangChain, Llama Index, and so on. And the last thing that is interesting to see is the out-of-the-box security analytics to help detect, investigate, and respond to issues that arise in real time. So these are the main use cases, and I want to drill down into these. And we'll start, obviously, with search, because this is the core of this conference and also the core of the project. And you'll find the regular functionalities that you'd expect. Full text search, of course, unstructured data, potentially also structured, of course. Relevance scoring, obviously the Lucene's native BM25 is supported, as well as others. Faceting, so geospatial coordinates, bounding boxes, and so on. Fuzzy matching, re-ranking, very interestingly, we see that obviously with user behavior, domain-specific knowledge, and what we see now with the trend around machine learning is that people plug in machine learning models to learn the patterns and start using that for more dynamic re-ranking. So pretty cool use cases coming around re-ranking that's ML-based. Observability. In the observability front, you can use OpenSearch to detect, diagnose, remedy issues. Log analytics is the classic. People throw all their logs, primarily unstructured, onto OpenSearch and then start slicing and dicing these. Lots of functionalities. Obviously, there's the discover pane that lots of people just use the raw logs and query them. You can query using Lucene. There is also another language that we offer, PPL, piped processing language, that allows, for those who are not native to Lucene, this could be an interesting alternative. It's also interesting because it's not just for logs, it's very useful also for metrics and traces. You have other features for log analytics like log tail, log surround, log patterns that will allow you to get more out of your logs. There's also integration with best-of-breed open source stacks such as OpenTelemetry, Prometheus, and Jaeger. For those who are more on the DevOps side and the DevOps observability side, you'll see a whole ecosystem there. I mentioned the Data Prepper before, so a lot of things that come baked, including, for example, native OTLP support for the OpenTelemetry native protocol, and so on. So for observability, definitely interesting. And now let's talk about AI ML. Everything is AI ML in the conference this year. So many talked before me about the evolution of search from lexical search to semantic search, and then to maybe to hybrid, essentially. And we've seen with the trend of a new wave of use cases emerging with generative AI, Gen AI, definitely it was nice to see that OpenSearch project was well suited to cater for these, thanks to the vector database that it has embedded in it. So as you can see, we have the full-fledged vector database for storing dense vectors, dense vector embeddings, and running similarity search on them. You can see on the slide that support for both exact and approximate KNN algorithms, AGN, the SW, IVF, multiple engines are supported, Lucene, FAIS, and multimodal search is also supported, whether you have your text, or your PDFs, or your videos, audio, images, whatnot. You can throw them and search on them as well. Also, in addition to the dense vectors, it also supports neural sparse search out of the box. And, of course, bring your own LLM. So that was the headlines, but let's see how it's done in practice. So what you see, obviously, you send your data in different, with different modalities in it, audio, video, PDF, as we mentioned, to OpenSearch Core, where you have the ML transformer models invoked to generate the embeddings. And then it's indexed, placed, and they're made available for all kinds of ML-driven search applications. So this is the core. And of course, vectors, you know, OpenSearch has grown from millions, storing millions of vectors to all billions and more. And as you know, it can be intense, and with using traditional CPU-based processing is becoming time-consuming and also cost intensive. So in order to solve that, we've released GPU-based acceleration for indexing embeddings. And shout out to the NVIDIA folks that drove this contribution. Really nice to see the involvement. By the way, also Uber did a great job here, also helping us because, you know, they want to leverage the GPU acceleration for their large search platform, and they've pitched in. So really nice to see the involvement of major community members in this feature. So the beauty of all this Gen AI-powered use cases, the relevancy of your search results can be bolstered by all these plethora of large language models out there, and we see new LLMs coming in every day, literally. So with OpenSearch, we have an easy way to integrate with all these models as they come out through the ML Commons, which is an ML-based library with blueprints for integrating into all these models. You hear some out-of-the-box connectors to Cohere, OpenAI, and DeepSeek. Actually, DeepSeek is a fascinating example. That's a recent example. And I think it was so easy to implement that from the day that they released DeepSeek to the time that we have the connector already available by the community, it took just 2 days. That's how readily accessible ML Commons library is to create new connectors to new models as they come up. And shout out here to ByteDance, who contributed a lot of valuable work to the ML Commons library. So that's about the AI ML. Now, another area, big area of focus of development has been UX, the user experience around the project, because, you know, we all see the sheer volume that we deal with, whether you come from observability or from search or whatnot, and the complexity is becoming really overwhelming. And OpenSearch wants to provide you with powerful, easy to navigate tools to manage and visualize your data, to identify and respond to issues quickly, to share insights within your team, across the teams, and it all needs to be accessible, intuitive, and with, you know, managed permission control and so on. So this is the goal with OpenSearch dashboards. Lots of features, as you can see on the screen. Maybe I will give one favorite one that has come up. And again, talking about machine learning and AI, is the OpenSearch Flow, which is a UI toolkit that lets you iteratively build and test workflows containing ingest and search pipeline. So in this example that you can see here on the screen, you get a sense of the user experience if you're looking to build semantic search with RAG, with retrieval augmented generation. So if you look here, I'll try and do this. Okay, so OpenSearch flow, essentially you create a workflow template, and very easy to define. You have different templates baked in for a custom search, for a hybrid search, for a RAG. This is the one that is demonstrated here, and so on. And using these templates, in this case, for example, the workflow builder helps you build an ingest pipeline, index, and search pipeline for performing vector search and RAG using deployed Titan text embedding model and the Anthropic Claude model. So very nice to see that. In this case, the Claude model is hosted on Amazon Bedrock, but of course you can use whichever LLM and whichever service that you like. So that's about the dashboards. Let's talk about performance. Performance has been a point of emphasis for the OpenSearch project, for the open source community in general. A lot of users choose OpenSearch for its ability to index, ingest, and store massive volumes of data effectively. But of course, with huge data sets, it comes with a premium both on the responsiveness, the real-time results that we want to get, and also the costs, whether indexing costs, whether storage costs, and so on. So a lot of work and a lot of features has come out to address that. Features such as segment replication, concurrent segment search, and so on. One of my recent favorites is actually star tree index that shows dramatic speed up of aggregations, up to 100 times reductions in query workloads. There was an interesting chat yesterday, a talk by Saurabh, for those who attended it, that he spoke a bit more about that. Very interesting. So that's an overview. Now I want to talk to you about what's new, and the hottest news. I couldn't be more excited to share about the next major release of OpenSearch, version 3.0, that came out just last month, so you get it hot off the press, not even 1 month old. And that's the first major release after 3 years. The 2.x started in 2022, so really exciting to see that. And the reason, by the way, OpenSearch follows semantic versioning, so we reserve the breaking changes to the major releases, and obviously for the stability of the community and to minimize the impact, we try to maximize as much as possible out of version 2.x, but now the community has decided the time is right, and the next big leap is needed, and trust me, it is big, so I want to show you why, just a taste of 3.0. And let's start with the infrastructure, okay? We've upgraded to Lucene version 10. Many of you know Lucene well to understand, but it essentially gives many benefits that come out of the box, like hardware level enhancement, SIMD vectorization, more efficient posting encoding, and more. Also on the JDK level, now the minimal JDK is 21 instead of 11 that was before. Again, lots of goodies that come with that. Node.js 14 is now the minimum for the JavaScript 3.0 client. So all of that is also cleanup, also makes the project more future-proof. And of course, note the breaking changes of a major release. You have the URL here at the bottom. Especially for SDK and plugin developers, of course, that's the main impact. So that's on the infrastructure level. Now, continue on the performance topic that I mentioned before. With 3.0 release, you're going to see OpenSearch performance take another big leap. Our initial measurements around the 3.0 release already showed performance improvements of 20% on aggregate across high-impact operations compared to the previous release, 2.19. And if you compare that to 1.3, you see, as you can see, testing at more than 9.5x faster across query types, so really exciting. And again, going to the vector side of things, great news also on the vector-powered applications. With a GPU acceleration that I mentioned before, you really see the impact. You really see the ability to deploy GPUs to get significant performance boosts. I think one of the things we've seen up to, you see 9.3x faster index build, 2 times faster, higher throughput, while reducing costs by more than 3x and decreasing CPU workloads by 2.5x. So really impressive results for the GPU acceleration. One of the biggest evolutions comes on the 3.0 with how OpenSearch ingests, transports, and manages data, and this follows from a push across the project to optimize resources, drive flexibility and scalability, and again, improve performance. That's a major theme, as you can see. So there are dozens of new features to support that. I'll just give three highlights to show you what it means. So first example is that with the 3.x line, we introduced support for gRPC and protobuf for the transport, both for client-server, later node-to-node communications, and that allows for faster and more efficient data transport and data processing for OpenSearch deployments. And also, very importantly, it unlocks the ability to use transport frameworks such as Apache Arrow and Apache Flight, which are optimized for large data sets and distributed networks. Again, yesterday was a very nice chat about these topics. I hope that you caught it. Also new in OpenSearch 3.0 is the pool-based ingestion. This gives you more control over the flow of data and when it's retrieved. So effectively, it creates decoupling between the source and the consumer, the producer and the consumer, and lots of flexibility there, but not only easier to optimize efficient ingestion, but also it means you'll be able to pull data from streaming frameworks such as Apache Kafka, Kinesis, Pulsar, Red Panda, and so on. So for those who are using the streaming frameworks, pretty cool update. Another significant architecture change in OpenSearch 3.0 is the reader-writer separation. So now you'll be able to keep your indexing and the search workloads separate. I think we see that in many use cases, whether you're, I don't know, a log analytics user with, I don't know, using millions of documents that you want to ingest per second, or maybe you're an enterprise that wants to configure 20 plus replicas to support e-commerce traffic. You can just have fine-grained elasticity on each one of the workloads separately. So really great thing on this side. Also, the OpenSearch project roadmap has more to do. We talked about vectors before, so adding capabilities of the vector engine has been top priority for the community. And this release includes a number of advancements in this space. Model context protocol support, MCP, GPU acceleration, development derived source for vectors. Just a few of the examples, and I'll zoom into these later, just to give you a sense. Also in the search, obviously core of everything, OpenSearch. So lots of advancement in 3.0 release. I'll talk about a few of these as well. Also, more and more users are building their observability pipelines around OpenSearch. So OpenSearch 3.0 brings new developments for those use cases. And lastly, on security, of course, always a priority. So with this release, OpenSearch replaced Java Security Manager, opening up new ways to fortify security at the platform level. And again, there are many more innovations at 3.0, too many to cover in this short talk, but I do want to dive deeper into a few features that would be of particular interest, I think, suspect to this audience. So first one, again, talking about AI and ML, is MCP, Model Context Protocol. Everyone, that's a hot topic these days. Everyone wants agentic AI, MCP. So great to see that OpenSearch 3.0 introduces native MCP support for both the server and the client side, enabling seamless integration with the AI agent. So MCP, I hope everyone knows what MCP is. Okay, so just quickly, it's an open protocol that standardizes communication between the LLMs, the data sources, and the tools, essentially. So with MCP, client support users can incorporate their existing tools and systems into the ML Common Agent framework. I showed that before, the one that connected the DeepSeek and Cohere and all of these. So you have that integration, enabling more comprehensive and customizable AI-powered solutions. On the server side, that was the client. On the server side, OpenSearch can now expose operations such as searching indexes and pulling index data exposed as tools making it easier to integrate OpenSearch with external AI agents such as Anthropic, LangChain, OpenAI, and so on. So that's on the MCP. Again, you have the QR code I tried to bring for the main features that you can have a look and read more about that. The second one I wanted to spend some time is the GPU acceleration. Vector operations are computationally intensive. We all know that, particularly at large scale. So this makes them ideally suited to parallel computing processing using GPUs. That's where GPUs excel, right? So this feature enables you to deploy GPUs to power index builds, to essentially significantly faster index creation. I showed you some stats before. You get obviously lower operational costs around that, enhanced fault tolerance as well. I haven't shown the stats, but very interesting to see the impact on fault tolerance, the stability. So according to benchmark tests, GPU acceleration can improve indexing speed by 9.3 times, while reducing costs by 3.75 times compared to CPU-based solutions. That's significant. And for more on how GPUs can help optimize your vector search, you have the QR code, as I mentioned before. Very nice blog post by our experts there from the community that developed it. And again, special thanks to NVIDIA team for the contributions to this groundbreaking functionality. Pool-based ingestion, again, I mentioned that briefly before. With that, OpenSearch, it allows OpenSearch Index to fetch data from streaming data sources and continue to load data into OpenSearch through the REST API as before. Essentially, a key advantage of the pool-based ingestion, as you can see here, is that it inherently handles the back pressure and the pace, the control of the data ingestion. So really nice to see. And as I mentioned, it also opens up the opportunity to leverage streaming platforms such as Apache Kafka and Kinesis and other data sources. So really nice functionality to check out. Derived sources for KNN vectors. Again, reducing storage consumption is a major thing with vectors. And this feature allows you to actually take the source itself and put it away from the index. So you don't need that. And that actually can improve by 1/3 the consumption, the storage consumption, by removing that redundant vector data sources and utilizing primary data and external data source to recreate the source documents as needed and for re-indexing or source callback. So very nice. Derived sources lets you access vector values during searching and re-indexing without the need to store them on the main cluster and take the time for that. And of course, removing that from the main JSON and dynamically injecting it, that's a major improvement. If you look at the stats, we saw delivering up to 30 times improvement in P90 cold start query latencies for the Lucene engine and reducing merge times by up to 40% across all engines. So really nice to see, and this functionality also demonstrates a 3 times reduction in storage costs across FAIS, Lucene, and NMSlib libraries. So really unlocking lots of optimizations on the vector workloads. Really nice to see that. Last bit is that I wanted to show. This release also includes a host of updates on hybrid search capabilities. Including, you can see here, Z-score normalization, which is more of a statistical approach to score normalization in hybrid search. So while the default score-based normalization, which is min-max, is nice for many of them, it can struggle with outliers. And in these cases, Z-score normalization excels by transforming the raw scores into standardized units. So if it's something that you've encountered before with the min-max, very interesting to look at the Z-score. Essentially, and you can see more here, the technique considers both the score distribution of each subquery and handles outliers effectively. So really nice. It makes the scores directly comparable across different score scales. So that's the way that the outliers get handled. Very nice. And very nice blog post, again, on the QR code that outlines all the details and the math behind it. So have a look at this. So that was about 3.0. And in the few minutes that I have left, I do want to tell you there are lots more features, and that's important. New functionality for search that I haven't had time to dig into, like semantic search highlighting for traditional neural and hybrid search queries to make search more meaningful when you visualize and you see these cool highlights. Concurrent segment search for KNN queries to accelerate queries by up to 2.5 times. Updates to star tree indexing to dramatically speed up aggregations and so on. So lots of other things. Do check out the 3.0. You have the URL here for the 3.0's full capacity. But I do want to tell you that we are not stopping here. Essentially, with 3.0 finally released, innovation can truly be unleashed now. So 3.1 is around the corner. Hard to believe that just last month we released 3.0 and 3.1 is already just around the corner. So stay tuned, sooner than you expect. And our public roadmap includes a long list of upcoming functionality across the OpenSearch use cases. I did want to highlight here some of the new tools that are in the pipeline for the 3.x line later this year that focus on search relevance and the search quality. I'm personally particularly excited about the search relevance workbench that will give you ways to view side-by-side comparison. You have some way to see here. Oh, sorry about that. Let me see. Here we go. It will be mentioned. Don't worry, my friend. He's very anxious because he's the speaker, but so you can see really nicely here. That's just a teaser. It doesn't replace the talk, of course, but essentially allow you to see side-by-side comparison between the different query variants to facilitate relevance tuning. And as mentioned here by distinguished members of the audience, if you're interested in learning more about these tools, do check the talks later today in this room at 2:50 by Eric Pugh and my friend here, Stavros, that will show you all about these goodies. Really, really exciting stuff that is coming in the upcoming 3.1 release and even more later in the 3.x line. So lots of goodies waiting. Stay tuned for this and for more on the 3.1 upcoming release. So if you want to learn more about all of that, I know that's been very packed, this talk, but check out this QR code where you can find the links. There's obviously the GitHub repos. We have over 130 GitHub repos, so you can zoom into the specific repos that are of interest for you. But very easy way to start is actually with the blogs and the forums. You can find them on opensearch.org. Lots of activity around the forums. There's an active Slack community, so check out the Slack workspace for that. You have all the links, by the way, in this one QR code, so you don't need to search too much. By the way, we have also user groups all around the world for local physical, if you want to get in-person meetings with fellow passionate practitioners of OpenSearch, including one here in Berlin. So if you're Berlin-based, there is a user group, and actually there's going to be a user group meetup day after tomorrow on the 19th, if I'm not mistaken, or is that 18th? 18th, apologies for that, 18th in the evening. You can find the details outside on the OpenSearch booth, which you can also come and visit us to learn more about that, to see demos. We have very cool demos about AI, machine learning, RAG, agentic AI, and all of these sexy topics. We have really, really nice visual demos that you can actually run and experiment with them yourself and see how it works. Conversational search, how you can carry on query like chatbots, say, and follow-up question, and zoom in onto your search by natural language querying. Very, very nice demo. So we have the booth here. We have the booth of the Eliatra folks that also help run and organize the local user group here in Berlin, so they can give you more details about the upcoming meetup. We have also the QR code there in the OpenSearch booth, and learn more about how you can join the local user group here. If you're based, by the way, somewhere outside Berlin and you're interested in starting a user group in a location where we don't have, we're also happy to talk to you and see how we can start more user groups or team you up with the user groups. The existing user groups, again, you can see on opensearch.org. All the user groups around the world, all go to meetup.com, where you'll see OpenSearch project and all the locations around the world where we have that. So these are the user groups. As I mentioned at the beginning of this talk, we also have the regional conferences, OpenSearch Con. We have them, one in Europe, one in North America. We just had a couple of weeks ago in India. We're going to have in Korea. So all around the world, definitely check that out. That's where, like, intense 2 days events where you get all the experts from all around the world. They fly in to bring their knowledge, the maintainers, the governance committee members, the technical steering committee members. Really exciting stuff to see. And follow us on these. We're looking forward to having you also taking part. It's open source like everything else. So if you are passionate about these topics, you want to get involved, happy to also pop by the booth. We're happy to tell you how you can get active with that, or just start hands-on with the project itself. I'm Dotan Horovits, and thank you very much for listening. And I think we have a few questions. Maybe we can give also a chance for the audience back home on the virtual.
Yes, so maybe I can take, if you have some question, while I check for the online audience. I don't see
no questions.
Any online question, and no question. It was already fully packed of new informations.
Anyway, if you're shy, we have the booth here, OpenSearch booth outside, and we have other experts of the project, maintainers, contributors that are more experts than me in some areas that will be happy to answer any questions.
Okay, shy or starving, I don't know.
It's okay. They're in a hurry for lunch. I think that's the main thing. Being before lunch.
Maybe.
Yeah.
Okay, so thanks everyone. Thanks Dotan.
Thank you very much.